Three, two, one. There we go. We're live. All right. So, welcome, Simon, to Enterprise MLOps interviews. The goal of these interviews is to get people exposed to real professionals who are doing work in MLOps. It's such a cutting edge field that I think a lot of people are very curious about. What is it? How do you do it? And very honored to have Simon here. And do you want to introduce yourself and maybe talk a little bit about your background?
Sure. Yeah, thanks again for inviting me. My name is Simon Stiebellehner, or Simon. I am originally from Austria, but currently working in the Netherlands, in Amsterdam, at Transaction Monitoring Netherlands. Here I'm the lead MLOps engineer. What are we doing at TMNL, actually? We are a data processing company, actually. We are owned by the 5 large banks of the Netherlands. And our purpose is kind of what the name says. We are basically lifting specifically anti-money laundering. So anti-money laundering models that run on pseudonymized transactions of businesses we get from these 5 banks to detect unusual patterns on that transaction graph that might indicate money laundering. That's in a nutshell what we do. So as you can imagine, we are really focused on building models, and obviously MLOps is a big component there, because that is really the core of what you do. You want to do it efficiently and effectively as well. In my role as lead MLOps engineer, I'm on the one hand the lead engineer of the actual MLOps platform team. So this is actually a centralized team that builds out lots of the infrastructure that's needed to do modeling effectively and efficiently. But also I am the craft lead for the machine learning engineering craft. These are actually, in our case, the machine learning engineers, the people working within the model development teams and cross-functional teams actually building these models. That's what I'm currently doing. During the evenings and weekends, I'm also a lecturer at the University of Applied Sciences, Vienna. And there I'm teaching data mining and data warehousing to master students, essentially. Before TMNL, I was at bol.com, which is the largest e-commerce retailer in the Netherlands. So I always tend to say the Amazon of the Netherlands, or Benelux, actually. It is still the biggest e-commerce retailer in the Netherlands, even before Amazon, actually. And there I was an expert machine learning engineer, so doing somewhat comparable stuff, a bit more still focused on the actual modeling part. Now it's really more on the infrastructure end. And well, before that, I spent some time in consulting, leading a data science team. That's actually where I kind of come from. I really come from originally the data science end. And there I kind of started drifting towards MLOps, because we started building out a deployment and serving platform that would, as consulting company, would make it easier for us to deploy models for our clients, to serve these models, to also monitor these models. And that kind of then made me drift further and further down the engineering lane, all the way to MLOps.
Great. Yeah, that's a great background. I'm kind of curious in terms of the data science to MLOps journey. That I think would be a great discussion to dig into a little bit. My background is originally more on the software engineering side, and when I was in the Bay Area, I did individual contributor and then ran companies at one point. I ran multiple teams, and then as the data science field exploded, I hired multiple data science teams and worked with them. But what was interesting is that I found that I think the original approach of data science, from my perspective, was lacking in that there wasn't really like deliverables. And I think when you look at a software engineering team, it's very clear there's deliverables. Like, you have a mobile app and it has to get better each week, right? Or else, what are you doing? And so I would love to hear your story about how you went from doing kind of more pure data science to now it sounds like MLOps.
Yeah, actually. So back then in consulting, which was still, at least back then in Austria, data science and everything around it was still kind of in its infancy. Back then, 2016 and so on, it was still really, really new to many organizations, at least in Austria. Austria might be some years behind the US and stuff. But back then it was still relatively fresh. So in consulting, what we very often struggled with was, on the modeling end, problems could be solved, but actually then easy deployment, keeping these models in production. At client side, that was always a bit more of the challenge. And so naturally, I started thinking and focusing more on the actual bigger problem that I saw, which was not so much building the models, but it was really more, how can we streamline things? How can we keep things operating? How can we make that move easier from a prototype, from a POC to a productionized model? And also, how can we keep it there and maintain it there? So personally, I was really more, I saw that this problem was coming up, and that really fascinated me. So I started jumping more on that exciting problem. That's how it went for me. And back then, we then also recognized it as a potential product in our case. So we started building out that deployment and serving and monitoring platform, actually. And that then really, for me, naturally, I fell into that rabbit hole, and I also never wanted to get out of it again.
So when the system that you built initially, what was your stack? What were some of the things you were using?
Yeah, so essentially we had, when we talk about the stack on the backend, there was a lot of so the full backend was written in Java. We were using more from a user perspective, the contract that we kind of had. Our goal was to build a drag and drop platform for models. So basically, the contract was, you package your model as an MLflow model, and then you basically drag and drop it into a web UI. It's going to be wrapped in containers. It's going to be deployed. There will be a monitoring layer in front of it based on whatever the data set is you trained it on. You would automatically calculate different metrics, different distributional metrics around your variables that you're using. And so we're layering this approach so that eventually every incoming request you would have a nice dashboard. You could monitor all that stuff. So stack-wise, it was actually MLflow, specifically MLflow models a lot. Then it was Java in the backend, Python. There was a lot of Python, especially PySpark component as well. It's been quite a while actually. There was quite some part written in Scala. Also, because there was a component of this platform was also a bit of an AutoML approach, but that died then over time, and that was also based on PySpark and vanilla Spark written in Scala. So we could facilitate the AutoML part, and then later on we actually added that deployment, the easy deployment and serving part. So that was kind of a lot of custom built stuff back then, right? There wasn't that much MLOps tooling out there yet, so you need to build a lot of that stuff custom. So it was largely custom built.
Yeah, the MLflow concept is an interesting concept because they provide this package structure that at least you have some idea of, what is going to be sent into the model, and like there's a format for the model, and I think that part of MLflow seems to be a pretty good idea, which is you're creating a standard where
exactly,
if in the case of if you're using scikit-learn or something, you don't necessarily want to just throw a pickled model somewhere and just say, okay,
exactly.
let's go.
Yeah, that was also our thinking back then. So we thought a lot about what could become the standard actually for how you package models. And back then, MLflow was one of the little tools that was already existent. And of course, there was Databricks behind it. So we also made a bet on that back then and said, all right, let's follow that packaging standard and make it the contract how you would, as a data scientist, then how you would need to package it up and submit it to the platform.
Yeah, it's interesting because this reminds me of one of the issues that's happening right now with cloud computing, where in the cloud, AWS has dominated for a long time, and they have 40% market share, I think, globally. And Azure's now gaining, and they have some pretty good traction. And then GCP's been down for a bit, in maybe the 10% range or something like that. But what's interesting is that it seems like in the case of all of the cloud providers, they haven't necessarily been leading the way on things like packaging models, right? Or they have their own proprietary systems which have been developed and are continuing to be developed, like Vertex AI in the case of Google, the SageMaker in the case of Amazon. But what's interesting is let's just take SageMaker for example. There isn't really like this, industry-wide standard of model packaging that SageMaker uses. They have their own proprietary stuff that kind of builds in, and Vertex AI has their own proprietary stuff. So I think it is interesting to see what's going to happen, because I think your original hypothesis, which is let's pick, this looks like it's got some traction, and it wasn't necessarily tied directly to a cloud provider because Databricks can work on anything. It seems like that in particular, that's one of the more sticky problems right now with MLOps is who's the leader, like who's developing the right, kind of a standard for tooling. I don't know, maybe that leads into kind of you talking a little bit about what you're doing currently. Like, do you have any thoughts about the current tooling and what you're doing at your current company and what's going on with that?
Absolutely. So at my current organization, Transaction Monitor Netherlands, we are fully on AWS. So we're really almost cloud native AWS, and so that also means everything we do on the modeling side really evolves around SageMaker. So for us, specifically for us as MLOps team, we are building the platform around SageMaker capabilities. And on that end, at least company internal, we have a contract how you must actually deploy models. There is only one way, what we call the golden path in that case. This is the streamlined, highly automated path that is supported by the platform. This is the only way how you can actually deploy models. And in our case, that is actually a SageMaker pipeline object. So in our company, we're doing large-scale batch processing. So we're actually not doing anything real-time at present. We're doing post-transaction monitoring. So that means you need to submit essentially DAGs, right? This is what we use for training. This is what we also deploy eventually. And this is our internal contract. You need to provision a SageMaker in your model repository. You gotta have one place. And there must be a function with a specific name, and that function must return a SageMaker pipeline object. So this is our internal contract, actually.
Yeah, that's interesting. I mean, and I could see like I know many people that are using SageMaker in production, and it does seem like where it has some advantages is that AWS generally does a pretty good job at building solutions, and if you just look at the history of services, the odds are pretty high that they'll keep getting better, keep improving things, and it seems like what I'm hearing from people, and it sounds like maybe with your organization as well, is that potentially the SDK for SageMaker is really the win versus some of the UX tools they have and the interface for Canvas and Studio. Is that what's happening?
Yeah, so I think, right, what we try to do is we always try to think about our users. So how do our users, who are our users, what capabilities and skills do they have, and what freedom should they have, and what abilities should they have to develop models? In our case, we don't really have use cases for stuff like Canvas, because our users are fairly mature teams that know how to do on the one hand, the data science stuff, of course, but also the engineering stuff. So in our case, things like Canvas do not really play so much role, because obviously, due to the high abstraction layer of more like graphical user interfaces, drag and drop tooling, you are also limited in what you can do or what you can do easily. So in our case, really, it is the strength of the flexibility that the SageMaker SDK gives you, and in general, the SDK around most AWS services. But also, it comes with challenges, of course. You give a lot of freedom, but also you're creating a certain ask, certain requirements for your model development teams, which is also why we've also been working about abstracting further away from the SDK. So our objective is actually that you should not be forced to interact with the raw SDK when you use SageMaker anymore, but you have a thin layer of abstraction on top of what you are doing. That's actually something we are moving towards more and more as well. Because it gives you the flexibility, but also flexibility comes at a cost, comes often at the cost of speed, specifically when it comes to the 90% default stuff that you want to do. Yeah.
And one of the things that I have as a complaint against SageMaker is that it only uses virtual machines, and it does seem like, a strange strategy in some sense. Like, for example, I guess if you're doing batch only, it doesn't matter as much. Like, which I think is a good strategy actually to get your batch based predictions very, very strong. And in that case, maybe the virtual machines make a little bit less of a complaint. But in the case of the endpoints with SageMaker, the fact that you have to spin up these really expensive virtual machines and let them run 24/7 to do online prediction, is that something that your organization evaluated and decided not to use, or like what are your thoughts behind that?
Yeah, in our case, doing real-time or near real-time inference is currently not really relevant, for the simple reason that when you think a bit more about the money laundering or anti-money laundering space, typically every individual bank must do anti-money laundering, and they have armies of people doing that. But on the other hand, the time it actually takes from one of their AML systems actually detecting something that's unusual, that then goes into a review process until it eventually, hits the governmental institution that then takes care of the cases that have been at least twice validated, that they look very unusual. So this takes a while. This can take quite some time, which is also why it doesn't really matter whether you ship, your prediction within a second, or whether it takes you a week or 2 weeks. It doesn't really matter. Hence, for us, that problem so far, thinking about real-time inference, has not been there. But yeah, indeed, for other use cases, for also private projects, we've also been considering SageMaker endpoints for a while. But exactly what you said, the fact that you need to have a very beefy machine running all the time, specifically when you have heavy GPU loads, right? And you're actually paying for that machine running 24/7, although you do have quite fluctuating load. Then that definitely becomes quite a consideration what you go for.
Yeah, and I actually have been talking to AWS about that because one of the issues that I have is that the AWS platform really pushes serverless, and then my question for AWS is, so why aren't you using it? Right? Like, I mean, if you're pushing serverless for everything, why is SageMaker nothing serverless? And so maybe they're going to do that. I don't know. I don't have any inside information, but it is interesting to hear you've had some similar concerns. I know that there's two questions here. One is, someone asked about what do you do for data versioning, and a second one is, how do you do event-based MLOps? So maybe kind of following up.
What do we do for data versioning? So on the one hand, we are running a data lakehouse, where after data we get from the financial institutions, from the banks, that runs through massive data pipeline. Also on AWS, we're using Glue and step functions actually for that. And then eventually it ends up modeled, to some extent sanitized, quality checked in our data lakehouse. And there we're actually using Hoodie on top of S3. And this is also what we use for versioning, what we use for time travel and all these things. So that is Hoodie on top of S3. When then pipelines, so actually our model pipelines, plug in there and spit out predictions, alerts, what we call alerts eventually. That is something that we version based on unique IDs, so processing IDs. We track pretty much everything, every line of code that is related to a specific row in our data. So we can exactly track back for every single row in our predictions and in our alerts what pipeline ran on it, which jobs were in that pipeline, which code exactly was running in each job. which intermediate results were produced. So we're basically adding lineage information to everything we output along that line, so we can track everything back using a few tools we've built.
So the tool you mentioned, I'm not familiar with it. What is it called again? It's called Hootie.
Hootie.
Hootie. Oh, yeah.
Yes.
What is it? Maybe you can describe it and
Yeah, Hootie is essentially, it's quite similar to other tools such as Databricks. How is it called? Databricks solution.
the Delta Lake, maybe.
Yes, exactly.
Oh, okay.
It's basically, it's equivalent to Delta Lake. Just that back then, when we looked into what are we going to use, Delta Lake was not open sourced yet. Databricks open sourced it a while ago. We went for Hootie. It is a layer on top of, in our case, S3 that allows you to more easily keep track of the actions you are performing on your data. Yeah. So it's essentially very similar to Delta Lake, just also already before an open source solution.
Yeah, I didn't know anything about that, so now I do. So thanks for letting me know. I'll have to look into that. The other, I guess, interesting stack related question is, what are your thoughts about? I think there's two areas that I think are interesting that are emerging. Oh, actually, there's multiple. Maybe I'll just bring them all up. So we'll do one by one. So these are some emerging areas that I'm seeing. So one is the concept of event-driven, architecture versus maybe like a static architecture. And so I think obviously you're using step functions, so you're a fan of event-driven architecture. Maybe we'll start with that one. Is what are your thoughts on going more event-driven in your organization?
Yeah, in our case, essentially everything works event-driven, right? So since we're on AWS, we're using EventBridge, CloudWatch Events, I think now it's called.
Yep.
Everywhere, right? This is how we trigger pretty much everything in our stack. This is how we trigger our data pipelines when data comes in. This is how we trigger different lambdas that parse out certain information from your log, store them in different databases. This is how we at some point in the past, how we also triggered new deployments when new models were approved in your model registry. So basically everything we've been doing is fully event driven. Yeah.
So I think this is a key thing you bring up here, is that I've talked to many people who don't use AWS, who are alternatively experts at technology, and one of the things that I've heard some people say is like, oh well, AWS isn't as fast as X or Y, like Lambda isn't as fast as X or Y, or Kubernetes or whatever. But the point you bring up is exactly the way I think about AWS, is that the true advantage of AWS platform is the tight integration with the services, and you can design event-driven workflows. Would you say that's
absolutely?
Yeah.
No, I think designing event-driven workflows on AWS is incredibly easy to do. Yeah. And it also comes incredibly natural, and that's extremely powerful, right? Simply by having an easy way how to trigger lambdas event-driven, you can pretty much do everything and glue everything together that you want. I think that gives you a tremendous flexibility.
Yeah. So I think there's two things that come to mind now. One is that if you are developing an MLOps platform, that you can't ignore Lambda. So because I've had some people tell me, oh well, we can do this and this and this better. It's like, yeah, but if you're going to be on AWS, you have to understand why people use Lambda. It isn't speed; it's the ease of developing very rich solutions, right?
Absolutely. It's the glue between what you are building eventually.
And you can even almost the thoughts in your mind turn into Lambda. You can be thinking and building code so quickly.
Absolutely. Everything turns into, which event do I need to listen to? And then I trigger a Lambda, and that Lambda does this and that.
Yeah. And the other part about Lambda that's pretty awesome is that it hooks into services that have infinite scale. Like, so SQS, like you can't break SQS. Like there's nothing you can do to ever take SQS down. It
Yeah.
handles unlimited requests in and unlimited requests out. How many systems are like that?
Yeah. Yeah,
So
absolutely.
yeah, so then this kind of a follow-up would be that maybe data scientists should learn Lambda and step functions in order to get to MLOps.
I think that yes, if you wanna put a foot into MLOps and you are on AWS, then I think there is no way around learning these fundamentals, right? There's no way around learning things like what is a Lambda, how do I create a Lambda via Terraform or whatever tool you're using there, and how do I hook it up to an event, and how do I use the AWS SDK to interact with different services. So, right, I think if you want to take a step into MLOps from coming more from the data science end, it's extremely important to familiarize yourself with how do you, at least the fundamentals, how do you architect basic solutions on AWS? How do you glue services together? How do you make them speak to each other? So yeah, I think that's quite fundamental. Ideally, I think that's what the platform should take away from you as a pure data scientist. You should not necessarily have to deal with that stuff. But if you're interested and if you want to make that move more towards MLOps, I think learning about infrastructure and specifically in the context of AWS about the services and how to use them is really fundamental.
Yeah, it's
Because
good.
this is automation eventually. And if you want to
Yeah.
automate, your complex processes, then you need to learn that stuff. How else are you going to do it?
Yeah, I agree. I mean, that's really what Lambda step functions are, is their automation tools. So
Yeah.
that's probably the better way to describe it. That's a very good point you bring up. Another technology that I think is an emerging technology is the managed file system. And the reason why I think it's interesting is that so I 20 plus years ago I was using file systems in the university setting when I was at Caltech, and then also in film industry. So film has been using managed file servers with um, uh, parallel processing farms for a long time. I don't know how many people know this, but in the film industry, the architecture, even from like 2000, was there's a very expensive file server, and then there's, let's say, 40,000 machines or 40,000 cores, and that's it. That's the architecture. And now what's interesting is I see with data science and machine learning operations that like that could potentially happen in the future is actually a managed NFS mount point with maybe Kubernetes or something like that. Do you see any of that on the horizon?
That's a good question. I think for our what we're currently doing, that's probably a bit further away. But in principle, I could very well imagine that. For our use case, not quite, but in principle, definitely.
And then maybe a third emerging thing I'm seeing is what's going on with OpenAI and Hugging Face, and that has the potential, but maybe to change the game a little bit, especially with Hugging Face. I think, although both of them, I mean, there is that, in the case of pre-trained models, here's a perfect example: is that an organization may have, maybe they're using AWS even for this. They're transcribing videos, and they're going to do something with them. Maybe they're going to detect, I don't know, like, if you recorded customers in your, I'm just brainstorm, I'm not saying your company did this, but I'm just creating a hypothetical situation that they recorded, customer talking, and then they transcribe it to text and then run some kind of a, criminal detection feature or something like that. Like, they could build their own models, or they could download the thing that was released 2 days ago or a day ago from OpenAI that transcribes things, and then turn that transcribed text into Hugging Face, some other model that summarizes it, and then you could feed that into a system. So it's what are your thoughts around some of these pre-trained models, and
Yeah.
are you thinking of, in terms of your stack, trying to look into doing fine tuning?
Yeah. So I think pre-trained models And especially the way that Hugging Face, I think, really revolutionized the space in terms of really kind of platformizing the entire business around, or the entire market around pre-trained models. I think that is really quite incredible, and I think really for the ecosystem a changing way how to do things. And I believe that looking at the costs of training large models, and looking at the fact that many organizations are not able to do it because of massive costs or because of lack of data, I think this is makes it very clear how important such platforms are, how important sharing of pre-trained models actually is. I believe we are only quite at the beginning actually of that, and I think we're going to see that. Nowadays, you see it mostly when it comes to fairly generalized data formats, right? Images, potentially videos, text, speech, these things. But I believe that we are going to see more marketplace approaches when it comes to pre-trained models in a lot more industries and in a lot more use cases where data is to some degree standardized. Also, when you think about banking, for example, right? When you think about transactions, to some extent, transaction data always looks the same, kind of, at least at every bank. Of course, you might need to do some mapping here and there, but also there is a lot of power in it. Yeah, but because simply also thinking about sharing data is always a difficult thing, especially in Europe. Sharing data between organizations is incredibly difficult. Legally, it's difficult. Sharing models is a different thing, right? It's basically similar to the concept of federated learning. Sharing models is significantly easier legally than actually sharing data. And then applying these models, fine-tuning them, and so on.
Yeah, I mean, I could just imagine. I really don't know much about banking transactions, but I would imagine, there could be several kinds of transactions that are very normal, and then there's some transactions like, if you're making every single second, you're transferring a lot of money, like, and it happens just very quickly. It's like, wait, why are you doing this? Why are you transferring money constantly? Like, what's going on? Or or that, like, huge sum of money only involves like 3 different points in the network, like over and over again. Just these 3 points are constantly, like what was. And so once you've developed a model that is anomaly detection, then yeah, why would you need to develop another one? I mean, somebody already did it.
Exactly. Yes, absolutely. And that's definitely right. That's encoded knowledge, encoded information in terms of a model, which is not abstracts away from the personally identifiable data. And that's really the power. That is something that, as I said before, you can share significantly easier, and you can apply to your use cases.
The kind of related to this, in terms of upcoming technologies, is I think dealing more with graphs, and so is that something from a stack wise that your company's investigated resources into?
Yeah. So when you think about bank transactions, right, and bank customers. So in our case, again, it's we only have pseudonymized transaction data. So actually, we cannot see anything, right? We cannot see names, we cannot see IBANs or whatever. We really can't see much. But you can look at transactions moving between different entities, between different accounts. You can look at that as a network, as a graph, and that's also what we very frequently do. You have your nodes in your network. These are your accounts or your persons even, and then the actual edges between them, that's what your transactions are. So you have this massive graph actually that also we as TMNL, as Transaction Monitoring Netherlands, are sitting on. We're actually sitting on a massive transaction graph. So yeah, absolutely. For us, doing analysis on top of that graph, building models on top of that graph is a quite important thing.
And like I taught a class a few years ago at Berkeley where we had to cover graph databases a little bit, and I really didn't know that much about graph databases, although I did use one actually at one company I was at. But one of the things I learned in teaching that class was about the descriptive statistics of a graph network, and it is actually pretty interesting because I think most of the time everyone talks about median and max min and standard deviation and everything, but then with a graph there's things like centrality and I forget all the terms off the top of my
Yeah.
head, but like you can see like if there's a node in the network that's like everybody's interacting with.
Absolutely. You can identify communities of people moving around a lot of money all the time, for example. You can detect different metrics, features eventually, right? Doing computations on your graph and then plugging in some model. Often it's feature engineering. You're computing between the centrality scores across your graph for your different entities. And then, so you're building your features actually. And then you're
Okay.
plugging in some model in the end. If you do classic machine learning, so to say, right? If you do graph deep learning, of course, that's a bit different.
So basically that could for people that are analyzing essentially networks of people or networks, then basically a graph database would be step one, is generate the features, which could be centrality, like there's a score, and then you then go and train the model based on that descriptive statistic.
Yeah, exactly. So one way how you could think about it is whether you need a graph database or not. That always depends on your specific use case and what database. We're actually also running that using Spark.
Okay.
Using, right, you have graph frames, you have graph X actually, so really stuff in Spark built for doing analysis on graphs. And then, yeah, what you usually do is exactly what you said. You are trying to build features based on that graph,
And
based on the attributes of the nodes and the attributes on the edges and so on.
and so the graph, I guess, in terms of graph databases right now, it sounds like maybe the three main players maybe are there's Neo4j, which has been around for a long time. There's I guess Spark, and then there's also, I forgot what the one is called for AWS. Is it
Neptune? That's
Neptune?
Neptune.
Yeah,
Yeah.
Neptune.
There's
Like, have you had
Graph is
some?
there as well.
Have you played with all three of those, and did you evaluate all three?
Neptune was something Spark, of course, we actually currently using for exactly that. Also because it allows us to keep our stack fairly homogeneous.
Okay.
We did also POC Neptune a while ago already. And well, Neptune, definitely you have essentially two ways how to query Neptune, either using Gremlin or SparkQL. So that means your data science actually need to get familiar with that, which then is already a bit of a hurdle, because usually data scientists are not familiar with either. But also what we found with Neptune is also that it's not necessarily built as an analytics graph database. It's not necessarily made for that. And that then it's sometimes, at least for us, it has become quite complicated to handle different performance considerations when you actually do fairly complex queries across that graph.
Yeah, so you're bringing up like a point which happens a lot in my experience with technology, is that sometimes the purity of the solution, it becomes the problem, where even though Spark isn't necessarily designed to be a graph database system, the fact is people in your company are already using it. So if you just turn on that feature, now you can use it, and it's not like this huge, technical undertaking and retraining effort. So even if it's not as good, if it works, then that's probably the solution your company will use. Versus, I agree with you. Like, a lot of times, even if a solution like Neo4j is a pretty good example of, like, it's an interesting product, but if you already have all these other products, like, do you really want to introduce yet another product into
Yeah.
your stack?
Yeah, because eventually, right, it all comes with overhead, of course. Introducing it, that is one thing. It requires someone to maintain it, even if it's a managed service. Somebody needs to actually own it and look after it. And then, as you said, you need to retrain people to also use it effectively. So it comes at significant cost. And that is really something that I believe should be quite critically assessed. What is really the gain you have? How far can you go with your current tooling? And then eventually make that decision. It's not, at least personally, I'm really not a fan of thinking tooling first. But personally, I really believe in looking at your organization, looking at the people, what skills are there, looking at how effective or ineffective are these people actually performing certain activities and processes, and then carefully thinking about what really makes sense. Yeah, because
Yeah, that's
tooling
a
is one thing, but people need to adopt and use the tooling, and eventually it should really speed them up and improve how they develop.
yeah. I think that's great advice. That it's hard to understand how good of advice it is because it takes experience getting burned, creating new technology. I've had experiences before where one of the mistakes I've made was putting too many different technologies in an organization. And the problem is once you get enough complexity, it can really explode. And then this is the part that really gets scary is that, like, let's take Spark, for example. How hard is to hire somebody that knows Spark? Pretty easy.
Yeah.
How hard is it going to be to hire somebody that knows Spark and then hire another person that knows the Gremlin query language for Neptune, then hire another person that knows Kubernetes, then hire another. Like after a while, if you have so many different kinds of tools, you have to hire so many different kinds of people that all productivity goes to a stop. So it's the hiring as well.
Absolutely. It's virtually impossible to find someone who is really well versed with Gremlin, for example. It's incredibly hard. And I think tech hiring is hard by itself already. So you really need to think about, what can I hire for as well? What expertise can I realistically build up?
Yeah, and so that's why I think AWS, even with some of the limitations about the ML platform, the advantages of using AWS is that you have a huge audience of people to hire from. And then the same thing like Spark, there's a lot of things I don't like about Spark, but a lot of people use Spark. And so if you use AWS and use Spark, let's say those two, which you are, then you're going to have a much easier time hiring people. You're going to have a much easier time training people. There's tons of documentation about it.
Mm.
So I think a lot of people, like, I think it's very wise that you're thinking that way, but a lot of people don't think about that. They're like, oh, I got to use the latest, greatest stuff and this and this and this. And then their company starts to get into trouble because they can't hire people, they can't maintain systems, and then
Mm.
productivity starts to decrease.
Yeah, and also it's also something not to ignore is the cognitive load you put on a team that needs to manage a broad range of very different tools or services, right? It puts incredible cognitive load on that team, and you suddenly also need an incredible breadth of expertise in that team, and that means you're also going to create single points of failures if you don't really scale up your team. It's something to really. I think when you go for new tooling, you should really look at it from a holistic perspective, not only about this is the latest and greatest.
And in terms of Europe versus US, have you spent much time in the US at all?
Not at all, actually. Flying
Okay.
to the US Monday, but no, not
Ah,
at all.
okay. Yeah, I think that also would be kind of an interesting comparison in that the culture of the United States is really this culture of I would say more like survival of the fittest, or you work 7 days a week and you're constantly like you don't go on vacation and you're proud of it, and I think there's the it's not a good culture. I'm not saying that's a good thing. I think it's a bad thing, and that a lot of times the critique people have about Europe is like, oh well, people take vacation all the time and all this, and as someone who has spent time in both, I would say yes, that's a better approach. A better approach is that people should feel relaxed, because when especially the kind of work you do in MLOps, is that you need people to feel comfortable and happy, and so more of the question what I was going to is that uh, is that I wonder if there is a more productive culture for MLOps in Europe versus the US in terms of like maintaining systems and building software, where the US, what it's really been good at, I guess, is kind of coming up with new ideas, and there's lots of new services that get generated, but the quality and longevity is not necessarily the same. Where I could see in like the stuff we just talked about, which is if you're trying to build a team where there's low turnover, you have like very high quality output. It seems like that, maybe organizations could learn from the European approach to building and maintaining systems for MLOps.
Yeah, I think there's definitely some truth in it. So especially when you look at like the median tenure of a tech person in an organization, I think that is actually still significantly lower in the US. I'm not sure. I think in the Bay Area it's somewhere at 1 year, 2 months, or something like that.
Wow.
Fairly compared to Europe, I believe still fairly low. Here, of course, in tech, people also like to switch companies more often, but I would say average is still more around 2 years, something around that, staying with the same company, also in tech, which I think is a bit longer than you would typically have it in the US. I think it, from my perspective, where I've also built up most of the current team, I think it's super important to hire good people, but also, and people that fit to the team, fit to the company culture-wise, but also give them, let them not be in a sprint all the time, right? It's about having a sustainable way of working, in my opinion. And that sustainable way means you should definitely take your vacation. And I think usually in Europe, we have quite generous, even by law, vacation. I mean, here in the Netherlands, by law, you get 20 days a year, but most companies give you 25. Many IT companies, 30 per year. So that's quite nice, and people do take that. So culture-wise, it's really, everyone likes to take vacations, whether that's C-level or whether that's an engineer on a team. And that's in many companies, that's also really encouraged to have a healthy work-life balance. And of course, it's not only about vacation, it's also about giving growth opportunities, letting people explore, develop themselves, and not always pushing on max performance, but also really, at least I always see it like a partnership, right? The organization wants to get something from an employee, but the employee should also be encouraged and developed in that organization. And I think that is something that in many parts of Europe, where there is big awareness for that.
Yeah, and my hypothesis is that it's possible that Europe becomes the new hub of technology, and I'll tell you why. Here's my hypothesis. The reason why is that in terms of machine learning operations, I've already talked to multiple people who know the data around it, like big companies, and they've told me that it's going to be close to impossible to hire people soon because essentially there's too many job openings. There's not enough people that know machine learning operations, cloud computing. And so the American culture, unfortunately, I think, is so cutthroat that they don't encourage people to be loyal to their company. And in addition to that, because there is no universal healthcare system in the US, it's a kind of a prisoner's dilemma where nobody nobody trusts each other, and so like they're constantly kind of optimizing. But if in the case of machine learning, it's a different kind of a industry where you do really need to have some longevity for employees because the systems are very complex system to develop. And so if the culture of Europe, which is much more friendly to the worker, I think it could lead to Europe having basically a better outcome for machine learning operations. So that's one part of it, and then the second part of it is the other thing the U.S. has done that I think Europe is done that if I compare Europe versus the U.S. in terms of data privacy, that I think the U.S. has dropped the ball and they haven't done a good job at it. but Europe has actually done much, much better at holding tech companies accountable. And I think if you asked well-informed people if they would like some of the practices of the United States tech companies to change, I think most well-informed people would say, we don't want you to recommend bad data, like extremist video content. I mean, there's people that are extremists that love it, if or we don't want you to sell our personal information without our consent, and so it could also lead to a better um, uh, like a better outcome for the people that are using machine learning and AI in Europe. So I actually suspect, and this is my hypothesis, who knows if I'm true or not, is that I think Europe could be the leader from, let's say, 2022 to 2040 in AI and ML because of the culture. But I don't know. That's just one hypothesis I have.
Yeah, I think around what you mentioned before around the fact that perhaps turnover in tech companies here in Europe is less. I think that definitely helps you build systems that survive the test of time as well, right? I mean, everyone had the case when a key engineer off boards from a team leaves the company, and then you need to hire another person, right? It's long times of not being super productive, long time not being super effective, so you continuously lose track that you need. So I think you could be right there that in the longer run, when systems really need to be matured and developed over a longer time, Europe might have an edge there, might be a bit better suited to do that. Salaries are still higher in the US, and also I think many US companies are starting to enter more from a people perspective, given remote work and everything. They're starting to also poach more and more engineers from Europe, because of course vacation and everything and having a healthy work-life balance is one thing, but for many people, if they give you a 50% higher paycheck, that's also a strong argument.
Yeah.
So it's difficult actually to also for Europe to keep the engineers here, that as well. And
no, I will say this though: if you work remote from Europe, that's a very different scenario than living in the U.S.
yeah,
because
it's cheaper here.
I don't. You'll see when you. Unfortunately, the United States since about 1980 has declined, and the data around the U.S. is pretty dire actually. The life expectancy is one of the lowest in the world for a G20 country. so they're and then if you walk through the major cities of the US, there's just poverty everywhere. Like people are living in very low quality conditions, where every time I go to Europe, I go to Munich, I go to London, I go like wherever, that basically the cities are beautiful and well maintained. So I think if the case is that if a US company let a European live in Europe and work remote, yeah, that could work out, because the European citizen has, or an EU citizen has amazing healthcare. They have like the social safety net. Their cities aren't basically highly unequal. But I think it's the location of the US in its current form. I personally wouldn't recommend someone from Europe moving to the US, because unfortunately I think it's I don't think it's a great place to live, just to be totally honest. Versus if you're already in Europe, and on the flip side, I think that there's a lot of Americans actually who are very interested in universal healthcare in particular. Is not even possible in the US because of the politics in the US, and a lot of medical bankruptcies occur. And so from a startup perspective as well, this is something that people don't talk about. Is in America, it's like, yeah, we're all about startups. Well, think about how many more people would be able to create a company if you didn't have to worry about going bankrupt if you broke your arm, right? Or you have some kind of sickness or whatever. So I think it's an interesting, kind of trade-off situation, and I would say that the sweet spot might be you work for an American company and get the higher salary, but you still live in Europe. That would be the dream scenario.
I think that's why many people are actually doing it. So I think especially since COVID started, you can really see it. Before that, it wasn't really a thing. Working for a US company who really sits in the US and you're fully remote. But I think now, since 2.5 years, it's really becoming reality. Actually,
Interesting. Yeah. Well, um, great hearing a lot of your ideas around MLOps and what you're doing, and also about how you use SageMaker. Is there any place that someone can get a hold of you if they listen to this on the O'Reilly platform, or think content that you're developing yourself, or any other information you want to share?
yeah, definitely. So I think best place to reach out to me, and I'm always happy to receive a few messages and have a good chat or a virtual coffee even, is via LinkedIn. Right, my name is here. That's how you can find me on LinkedIn. I'm also at conferences here and there. Well, in Europe mostly. Typically, when there is an MLOps conference, you're probably going to see me there in one way or another. That is something as well.
Cool. Yeah. Well, I'm glad we had a chance to talk. You taught me a few things that I'm definitely going to follow up on, and I really appreciate it. And hopefully we can talk again soon.
Thanks a lot for the chat.
Okay. All right.